Hello friends, how are you? A very warm welcome to all of you for Manoj chemistry classes. So in this video we are discussing the topics what we are left in the earlier class. So before starting the video, I would like to request all of you, please subscribe my channel and like, share, comment. So I request all of you once again, please subscribe my channel. If you had any doubt, you should comment on the given comment box. So here in this lesson we are discussing classification of organic compounds. So here the organic compounds can be classified in three ways. The first one, classification is based on the carbon chain. This one is already discussed. So the next one is the classification based on functional groups, and the third one is classification is based on homologous series. So in this part we are discussing these two classifications, that is based on the functional group and homologous series. So once again I am requesting you, please subscribe my channel. So here coming to the next one, functional group. So what is meant by functional group? Here functional group is nothing but a group of atoms which are joined in a specific manner. It's a molecule which is responsible for the characteristic chemical properties in a compound. For example, if you take alcohol, OH is a functional group. It is a combination of oxygen and hydrogen. So it is responsible for the functional group of all the alcohols. Similarly, aldehyde CHO, it is also responsible for the characteristics of the properties of that particular compound. That means the property of that particular compound is depends on these functional groups, such as either COOH is known as carboxylic acid, such as aldehyde, alcohol, etc. So these are the group of atoms which are responsible for the chemical properties of the molecule or compound. Those are as a functional group. So here I give you some list of functional group. So the remaining are I upload in the PDF in the given description box. So here for example, if you observe here a double bond C double bond C, which is known as alkene. Some example is RCH double bond CH2. So C double bond C, if a carbon, a molecule which is containing a double bond in between two carbon atoms, that is known as alkene. Similarly, if it has a triple bond in between two carbon atoms, that is known as alkyne. So already discussed you, these alkenes are having sp2 hybridized, so whereas these alkynes are having sp hybridized. If a compound having only an X indicate a halogen, whether it may be chlorine, bromine or iodine, whatever it may be, so those are known as chlorine, bromine or iodine or fluorine. Those are known as halogens. So here if a compound is having halogen, that is known as halides. So the general example is RX. Similarly, the OH is known as alcohol. So the compounds which are containing OH as a functional group are known as alcohols. Similarly, if the compound having a functional group SH, it is known as thiol. So whereas the compound containing C double bond OOH, it is known as carboxylic acid. So it is known as acid or carboxylic acid. The general formula of carboxylic acids is RCOOH. So the general formula of carboxylic acids is RCOOH. So coming to the next one, CHO, which is known as aldehyde, C double bond O and H. So which is known as aldehyde. The general formula of aldehydes is RCHO. Whereas C double bond O, which is known as ketone, the general formula is RCO R dash, which is a ketone. Whereas C double bond S, which is known as thioketone, the difference between ketone and thioketone, in the ketone C double bond O is there, whereas in the case of thioketone C double bond S is there, which can be represented as generally RCSR. Whereas either RCOR dash, the general formula of either is RCOR dash, which has a oxygen which is linked between two carbon atoms, single bond. So oxygen has two single bonds which are linked to different carbon atoms. Similarly, if a sulfur is linked to two different carbon atoms, that is known as thioether. Thio meant for sulfur. The general formula of thioether is RSR. So here I have given only some functional group. The remaining functional groups I have uploaded in the given description box with the PDF format. So coming to the next one, homologous series. So what is meant by homologous series? Homologous series are nothing but a series of compounds which are differed by a successive of CH2 unit, or a 14 unit mass Those are known as homologous series. So homologous series are structurally similar compounds. These are structurally similar compounds which are differ either preceding or succeeding by a member of CH2 group that is known as a homologous series. So here these homologous series can be similarly if you go for a compound of alcohols, ROH, the general formula of alcohol is ROH, CH3OH is an alcohol, C2H5OH is another alcohol, similarly C3H7OH is a propyl alcohol. All these are alcohols which are differ with a CH2 unit. So these are also examples of homologous series. Coming to the next one, there are some characteristics are there for the homologous series. Let us discuss each one by one. The compounds are in the series of composed of same elements. These are composed of same elements and contains the same functional groups. Just now we are discussing regarding the alcohols. All these are having same functional group OH. So those are containing similar functional groups or same functional groups. These homologous series. Coming to the next one, these can be represented by a general formula. For example, if you are taking alkanes, those are having a general formula of CnH2n plus 2. Similarly, alcohols, the general formula of alcohol is CnH2n plus 1 OH. So this is the general formula of alcohols, saturated alcohols. So generally these homologous series can be represented with a general formula. The molecular mass of adjacent groups are differ by 14 units. For example, CH4, C2H6, these two are differ by 14 units. CH2 is differ. So the compounds which are differed by the 14 units are called as homologous series. The compounds have similar chemical properties. Why? Because all are having same functional group. So the chemical properties are depends on the functional group only. So those compounds which are having similar functional groups, that's why these are having similar chemical properties. Coming to this next one, there are regular gradation in the physical properties. Maybe the mass, all the compounds which are having mass is increased by the 14 units. So if the mass is increased, similarly density is increases. Like that, the physical properties are there, regular gradation is there. So coming to the next one, general methods of the preparation is almost similar. Why? Because all are having same chemical formula. That means same functional group. So that's why we can easily prepare the same functional group with a similar chemical property, as those are having similar chemical properties. So that's why the general methods of preparation is almost similar. So coming to the next one, classification of carbon and hydrogen atoms. The carbon and hydrogen atoms can be classified into two types. Classified into how many types? Two types. So it depends upon the arrangement of carbon atoms. Coming to the next one, depends upon the relative position of the carbon atoms. So it can be classified into two types. The first one is arrangement of atoms. So next one is relative position of the carbon atoms. So let us discuss the first one. Depends on the mode of arrangement of carbon atoms. So here the mode of arrangement of carbon atoms, there are four types of arrangements are there. So we can classify the carbon atoms into four types. The first one is primary carbon atom. So if a carbon atom which is said to be primary, it should be linked with only one different carbon atom. That is known as primary carbon atom. This one is primary carbon atom. If the carbon atom is linked to only one other carbon atom, that is known as primary carbon atom. So whereas the secondary carbon atom, if the carbon atom what we are going to discuss is linked with two or different carbon atoms. For example, if you consider this carbon atom which I marked with red color, so this one is combined with two different carbon atoms. So if the carbon atom is attached with two different carbon atoms, that is known as a secondary carbon atom. Similarly, if the carbon atom which is attached to three different carbon atoms, so for example, if you take the carbon atom which is marked in yellow color, is attached to three different carbon atoms. If this is the first one, second one, and third one, three different carbon atoms. Hence, it is known as a tertiary carbon atom. So similarly, quaternary carbon atom means if the carbon atom which is attached to four different carbon atoms, the carbon atom which is attached to four different carbon atoms is known as a quaternary carbon atom. For example, if we consider this carbon atom which is attached to four different carbon atoms, hence it is known as quaternary carbon atom. So here carbon atoms are four types. The first one is primary, secondary, tertiary, and quaternary. Whereas the primary is attached to only one carbon atom, the secondary is attached to two different carbon atoms, whereas the tertiary is attached to three different carbon atoms, whereas quaternary is attached to the four different carbon atoms. The hydrogen atoms which are attached to these carbon atoms, primary, secondary, tertiary, are known as primary, secondary, tertiary hydrogen atoms respectively. For example, if an hydrogen atom which is attached to the primary carbon atom, for example, this one is primary carbon atom which is attached to this one, hence it has two primary hydrogen atoms. The hydrogen atoms which are attached to primary carbon atom are known as primary hydrogen atoms, whereas the hydrogen atoms which are attached to tertiary are known as tertiary hydrogen atoms. So here a note, quaternary carbon atom which doesn't have any hydrogen atoms, why? Because all the valencies of the carbon is satisfied with the four different carbon atoms, hence there is no chance of adding a hydrogen atom, that's why it doesn't have any hydrogen atoms. Coming to the next one, the classification is only for saturated hydrocarbons. Thus, the classification of primary, secondary, tertiary carbon atoms or quaternary carbon atoms is only meant for saturated carbon atoms. It is not for unsaturated carbon atoms. For example, if you consider this example, so this one, if you consider this carbon atom, it is attached to only one carbon atom, hence it is primary. If you consider this carbon atom, this one is attached to two different carbon atoms, hence it one is a secondary. This one is attached to one, two, three different carbon atoms, hence it is a tertiary. Whereas this one is a quaternary carbon atom. Whereas this one is primary carbon atom, this one is primary carbon atom, this one is primary carbon atom, this one is primary carbon. Because all these four are attached to only one different carbon atom only. For example, if we consider this one is attached to only one different carbon atom. So similarly, all these four are attached to only one different carbon atom. So that's why these are known as primary carbon atoms. So finally, let us discuss the summary. So number of primary carbon atoms, here it has 1 2 3 4 5 primary carbon atoms, whereas the next one, the secondary carbon atoms, it has only one secondary carbon atom, whereas the next one, it one has only one tertiary carbon atom, whereas it has only one quaternary carbon atom. So similarly, the hydrogen atoms which are primary hydrogen atoms are here 3, here 3, here 3, here 3, here 3. So totally 1 2 3 4 5, 5 into 3, 15 primary hydrogen atoms are there. Whereas coming to the next one, secondary, only two secondary hydrogen atoms are there, secondary are 2. Whereas tertiary, it has only one tertiary hydrogen atom, whereas quaternary, I told you quaternary carbon atom doesn't have any hydrogen atoms. So this is a summary. Coming to discuss one more example, let us discuss one more example. Here this carbon atom is attached to, this carbon atom is attached to 1 2 3 different carbon atoms, hence this one is a tertiary carbon atom. Here this carbon atom is attached to only one carbon atom, hence it is known as primary. This carbon is also attached to only one carbon atom, hence it is known as primary. This one is attached to 1, 2, 3 carbon atoms, hence it is known as tertiary. This one is attached to 1, 2 carbon atoms, hence it is known as secondary. This one is also known as a primary. So this is the classification based on the relative position of the carbon atom. So here, so I would like to request you do this one as homework. Let us take a screenshot. 1, 2, 3, 4, 5. Okay, I hope all of you take a screenshot. So next one depends on the relative position of the carbon atom. So here depends on the position of the carbon atom. It can be defined into 3 carbon. Generally we are going to discuss 3 types only, that is known as alpha, beta and gamma. Here alpha carbon atom means the carbon atom which is adjacent to or directly attached to functional group is known as alpha carbon atom. So for example, if you are taking CH3 CH2OH, here this one is a functional group which is directly attached, hence it is known as alpha carbon atom. So whereas beta carbon atom means the carbon atom which is next to alpha carbon atom, this one is known as beta carbon atom. So similarly gamma carbon atom is known as the carbon atom which is next to beta carbon atom is known as a gamma carbon atom. For example, I would like to take a ketone which is having 5 more than 6 carbon atoms. Here this one is alpha, this is also alpha. Why? Because this one is a functional group. It has 2 alpha carbon atom. Next to alpha is beta, next to beta is gamma. So this one is beta, this one is gamma. So if one more is there, let it be, this one is known as delta carbon atom. So here we can go for up to 4 different types of carbon atom which depends on the relative position. So the carbon atom which is directly attached to the functional group is known as alpha, next one is beta, next one is gamma carbon atoms. So coming to the next one, nomenclature of organic compounds. The organic compounds are given 2 types of nomenclature. The first one is trivial system. So next one is IUPAC system. Trivial system and IUPAC system. In this class we are going to discuss only trivial system. The IUPAC system will be discussed in the next video. So coming to the next topic, trivial system. Trivial system is that names which are assigned based on the origin or the certain properties. Origin means from where it was prepared, from which compound it was prepared. So generally this trivial system is also known as common names. The trivial names is also known as common names. For example, if you take urea, it was prepared from urine. Methyl alcohol, if you take methyl alcohol, it is known as wood spirit. Why? Because it was prepared from methyl. Here myth means wine, hul means wood. So this one is also known as wood spirit methyl alcohol. The general formula of methyl alcohol is CH3OH. So this one is known as methyl alcohol. Butyric acid, so this one is prepared from rancid butter. Rancid means so stale butter which is having foul smell, that is known as rancid butter. So next one is valeric acid. It was prepared from valerian. It was a shrub, a flowering plant. So next one is caproic acid. So this one is prepared from copra, which is nothing but a goat. So next one is malic acid, which is prepared from malum. Malum means apple. Generally apples contain malic acid. So these are some examples I given you. The remaining examples I upload in the PDF format. The link was given in the description box. The link was given in the description box. Yeah. So coming to the one more example, one more important. These were already frequently asking these two, Westron and Westrol. Here Westron is nothing but 1,2,1,2,2 tetrachloroethane. Westrone is a saturated compound, whereas Westrol OL is an unsaturated compound which is nothing but trichloroethene. Westrol is an unsaturated compound which is nothing but trichloroethane in whereas Westron is nothing but a saturated compound which is nothing but tetrachloroethane, 1122 tetrachloroethane. So these are some examples of these are some examples of trivial compounds. The remaining examples I collected so many examples, nearly 40 trivial names. All those trivial names are uploaded as a PDF format in the description. The link was given in the description. So I hope all of you friends understand the concept what we are discussing in this video. So thank you all of you. Request all of you, don't forget to subscribe my channel. So if you had any doubt, comment on the comment box, but don't forget to subscribe. Thank you.